I'm going to tell you guys real quick. I'm going to repeat about 2/3 of the stuff you just heard. So, if you got something better to do, places to go, people to see, things to do, now might be a great time to do that. Well, I don't have any cool jokes for you or anything like that. But, I'm going to kind of bring up something that I think we need to look at as an industry. And one of the things I think we need to realize is we're not the only thing in town. We're building 10, 20 wood-story buildings as we speak now. And if concrete, for whatever reason, is no longer competitive, they will. We do concrete frames. If we can't do that, the way we do it now is competitive, it'll be a steel frame. I think one of the things we need to figure out real quick is, or understand real quick is, we're not the only building in town. Just because we're the preferred material now, if we can't work out some of the issues we're talking about, and we can't eliminate clashes with expectations, then there's going to be other issues and other bigger things to look at. And one of the things I think to look at is look around at the person beside you. If we can't figure these out, they may not be here. And if you don't have anybody behind you, that may be you that's not here. So I think we need to look at this very, very closely as an industry rather than individual groups as we go through. So, I'm going to kind of give you the summation of this now. I made that statement. One of the big things I see is there's a great big difference in this world between an expectation and a requirement. And I think that's something you really need to understand, because if somebody expects something from you, that's cool. Then that might be it. But it's a world of difference between that expectation and somebody telling you this is what you agreed to do as a part of it. And a lot of times I see things that what Kevin and what Jason was talking about is not necessarily how we're doing what we're going to do to meet the carbon requirements and things like that, and what happens as a result of that. So, we work upstream. We fix this material, we bring it down to this level, we bring it down to this level, but along the way, the changes that you get in what you're accustomed to has grossly changed over time. So a lot of times the problems we have is we're trying to do things like what we used to do. Now, how many salespeople do I have? Okay, now, there's a whole bunch of titles for that: business development, sales engineer, sales associate. But what do salespeople do? They sell. Now, I don't know very many salespeople that sit down and review the specifications in the detail, go through the specifications, go through all the requirements in the specifications, go through the reference specifications, and look at that. So if you are selling ready-mix concrete, or you're selling your services to install a slab, that would probably make you an estimator or whatever, you need to really understand what you're agreeing to do. You need to understand what you're committed to do. So if you have something in the specs that requires you to have a global warming potential of something, you need to look at how that's going to affect you as you go through this. Now, good ones do it well, they sell. What happens to bad salespeople? They become tech service guys. Okay? Okay, so, salespeople group, they don't thoroughly read. Typically, they're not the personality to do that. Are you laughing at me?
I'm laughing. I said, what are you both?
So let me back. So Stephanie's question: if you're a salesperson in a tech service, you're either real good at one or both of them, or you're not good at either one of them. I have no idea. Sales is necessary. Okay, if you're a concrete contractor, if you're a ready-mix producer, you've got an investment of a bunch of things. You've got to do something to move that along. You've got to sell that service, but you also need to look at the risk. And Jason talked a lot about risk. Well, people, if you're taking risks, you need to be compensated for it. Because one of the things you need to look at is what the risk is and what the ramifications of the risk are. So, you need to understand what you're implied to do and what you agree to do. Now, I want to put in another thing about construction. There's several phases of construction. Jason, there's the design process, there's the construction process, there's the closeout process, and then there's the shakeout. Okay? But the end of this many times is, I'm not happy as the owner, so I'm not going to pay you. All right, so then you get into negotiations about getting paid and things such as that. So a lot of the things we talked about with these things gets us to that legal piece of it, where people aren't going to get paid, and then the ramifications for that. Now, concrete has changed and will continue to change. I'm going to give you guys a little secret. I don't dye my hair gray. It's natural. I'm old. Okay. I've been in the concrete industry a long time. I've seen a lot of the changes come through. Okay, but most of those changes has been customer driven or contractor driven. Let's think through it. You know, if you go back to when we had admixtures. So admixtures came about, they were accepted by the ready mix industry because they were a good thing. Slag came out, pumping came out. All of those things was determined by the marketplace. And this is a little different here. The changes we have now are not covered by the customer. They're required as part of that. So we don't get to choose about these many times. We have to do this. And this is something that's completely different than we've had in the past. Because we could choose not to use flies. We could choose not to use admixtures. But you can't get away from the changes in concrete measures that you have to abide by now. The other part I want to tell you is our industry is very fragmented. You have the material suppliers, you have cement, you have ready-mix producers. They typically do not always work together. If they're vertically integrated, there's a better shot at that. But most of the time, the cement producers make the cement to meet their requirements, produce that. They're normally market-driven to a point. You have concrete producers who produce concrete. You have concrete contractors. All of those typically do not work together. They typically are very fragmented. And now is the time that we need to work together as an industry and have an understanding of what happens upstream with cement, what happens at the contractor level. Now is the time we need to understand, work together as a group to collaborate that. And the other thing I'm going to say is probably going to get me in a little bit of trouble, but, you know, we got what we got. Concrete's going to have less cement, less clinker in it. Cement's going to have less clinker in it. So we've got what we got. So what we have to do is we got to figure it out. And if you bounce around with several committees here, you'll see days talking about various things that we have. All that's great. But what we have to do is figure out how to do this. So we got what we got. Let's move on. Okay, I'm going to tell you guys the second biggest secret in the concrete industry. It's very simple. It's not all about compressor strength. You know, you talk to a lot of people, concrete producers, you know, the thing they're worried about, do I make strength? Did I make strength? Did I make early strength? Whatever it is. If you look at the issues you see, there's way more problems associated with things in concrete other than strength. It has to do with placing concrete, consolidating concrete, slump loss, slump gain, all of those things are the issue. So if the only thing you're looking at is what can I do to get strength, things are going to probably be somewhat problematic. Now, I've had these slides for a number of years, but I never thought it's more appropriate to use than that. If you're going to have a successful concrete project, it's a team effort. So you have to have a concrete producer who selects materials for what's available to him in his particular area. He's going to prepare a mix design. A mix design has more to do with just compressors. How finishability, about slump loss. You need to think about all of these different things. He's got to patch it, deliver it, and then he has to have some level of quality control to make sure that what he is delivering to the project will meet the needs of the project. The other person you have to have is the contractor. Okay, the contractor's in a big change. Because now he's getting concrete that's different from what he's had in the past, or she has had in the past. So he's got to transport. Okay, if we've got form pressures, if you're looking at concrete walls, and you do concrete walls much over about 10, 15 feet, you've got this little issue because most forming systems are not designed to pull liquid head once you pass that. Now I've got a concrete mix that's got 20-30% less clinker in it than I had before. It may gain strength. A lot of times I may stick an admixture in it to retard the cut a little bit, get slump like it, So now I've got things that setting differently from what I have set in the past. And if you start looking at the formulas in ACI 347 for this, most of those are going to kick you up so you got a couple of feet an hour. Setting times are different. Protection periods may be longer. You may have other issues. Curing periods may be longer. And I'm not talking about this because the specifier told you to do this. You may have to do these things so you can produce a acceptable concrete finish as a part of this. The engineer. Okay. A lot of people in the engineering office think if I can draw it, you can build it. If you ever hear the term, we'll work it out in the field, you know you've got a problem like that. So it's very difficult many times to build what's drawn. But now I've got all these environmental concerns. And the other thing is, it may not be possible to meet the requirements in the contract documents with the local materials that you have in your area. And I think that's something that you need to look at. And if it's not possible, that needs to be discovered well before you build the project and put a price in on that as part of it. Okay, the testing agency. So, testing agencies, what do you do that? Well, they test concrete and they test it. But now, proper testing is more important. I've got concrete mixture that sets low. I need to be assured that I have proper protection, proper temperature for concrete surface. I need to make sure that I'm delivering those properly. So all of these things become a real issue in it. And I'm going to tell you the third biggest secret of concrete. We keep all of these hush-hush as a matter of fact. Different cements affect concrete and plastic hardened properties differently. So you can't drop out cement A and put in cement B. You can't change the cementitious materials around and just do that and expect the same thing. Now, low carbons are here to stay. Kevin covered this pretty good. We're at the tip of the iceberg. Type 1L cements are here. We're going to have more cements with less clinker. We're going to have concrete mixes with less clinker. And probably going to take a couple people off, but if you're a concrete ready-mix producer supplier, if you're a material supplier, and you think you could drop out whatever you have in terms of pounds per cubic yard of cement, replace it with another. You're going to drop out of 1 2 and put in 1L. That's all you're going to do. You've got a problem. And they make strength. It's not going to set the same. It's going to probably require a different admixture package. It's probably going to take a little bit more. And the other part is, you're going to have a hard time changing between type 1L cement. So let's think about it. So what Jason was saying, so the tolerance on the limestone is plus or minus 2.5%. That's a range of 5. Each one of the 1Ls has its own target. So I've got cement A that's got a target of 7.5. That means I can go from 5 to 10. If I've got one that's got a target of 10, that means it goes 7.5 to 12.5. If I've got the same admixture package and all of those in there, it's going to respond differently. So one of the things, if you're doing that, you need to look at that. You need to look at what happens as a result of this. Now, type 1-2s were the same, but type 1-2s did not vary as much as we're looking at with 1Ls. So one of the ways to avoid issues and challenges is to make sure you understand what you're providing other than just compressor strength. There's some other things we don't know. Okay, typically, not all, typically 1L cements require more water. So if it requires more water, then it requires more cement, but we typically don't do that. So we either add water or add admixtures. Right? Both of those typically increase shrinkage. If you look at C494, you'll see that if you have an admixture, you replace the same amount and drop the water in the concrete mixture that has the admixture, then you get more shrinkage as a result of it. So we've got different shrinkages. A good chance it could be more. I don't really think we know about that. I noticed there's a question there about that. I don't think we know. Full water cement ratio, we have the same way. Maybe better, maybe worse. I don't think we understand this, and I think it may take some time before we sort all of that out. I think there's a bigger problem. More shrinkage, slower setting in some cases, greater chances for cracking. I see a big change and how it responds to cold water. But one of the things you look at, if you look at a concrete mixture, you're looking at what's happening at 70 degrees, which is the golden temperature. And then if you drop that down to 50 degrees, I've seen steady times. So the first one is slow. So it may be 6 or 8 hours, like more than what we see. Now you're talking about something that's way there. Now the other part of this too is we're using a type 1. We're also using 20, 25, 30% flat bed bag, 35, 40, 50% slide. So we're doing all of these different things. And the thing that typically, as we sit here and speak today, that drives steady is clinker. You strengthen up and all these others, so you get more of an issue when you work through these. And I guess kind of one of the things is, you know, again, I said we're fragmented. It's not really about, you know, the carbon requirements for cement. It's important. But it's the carbon requirements for concrete. Now, how many ready-mix producers do I have? How many ready-mix producers do we have? Okay, you guys, there's so few of you guys we can talk bad about. Now, the question is, do you have to add more cement with a type 1? I've heard it up and down. I've heard it 10 pounds, 15 pounds. I've heard as much as 50. Now, whether they really need to do that or not, whether they just didn't do their research, the fact is they're doing it. Okay, so how much are we really helping ourselves on the big picture if we're decreasing one, yet we're increasing the amount we use? So I guess that gets to be an issue as a part of it. And again, how much, if you're doing that 80,000 square feet, which, you know, if he's doing 80,000 square feet, he's doing a good job, but if you're doing that, what kind of cement do you need for the setting characteristics you need? Okay. So, you know, I was asked to talk about, you know, when they clash. Well, one of the first things I'm going to say is an expectation is a whole lot different from a requirement. If somebody expects you to do something or thinks it would be a good idea for you to do something to reduce whatever carbon footprint, that's a whole thing that's completely different. Don't let an expectation turn into a requirement. Okay, I've got the bottom one is, especially if you cannot achieve it, and that's pretty obvious. Even if you can achieve it, don't let it turn into a requirement. If it's a requirement, you have to do that or to explain in great detail why you're not going to do that. Okay, so what do you get if you have clashes? If you can solve the problem, solve it. Now, I'm a big believer is people buy either from, mostly not from a specification, from a purchase order. So if you typically look at, there's a contract between the general contractor and the subs. There's a purchase order between whomever's buying concrete. So what did you agree to do as a part of that? So if part of what you have to do is going to increase your costs or increase your risk, that should be a change order or something that you ask or bring out as a part of that. And then the other part is, kind of, if you're a concrete producer and somebody says, gee, it's a good idea, you got to meet this GWP, we like you to meet this GWP or whatever, you just arbitrarily change the mix with 50% cementitious materials and supplementary without thoroughly understanding what happens other than strength, you've got a problem that's going to occur as a part of that. And again, it's not all about strength. It's about finishability, workability. So, if I develop a concrete mix, it's got 57,000 GHGs. It's impermeable to everything. If I can't place it, it's totally worthless. Doesn't matter how good it is, if you can't place it. You can't put it in the form of it. You can't consolidate. So one of the most important things for the concrete mixer is to be able to place the concrete in the formwork. Okay. Not meeting expectations is a nuisance. Okay. Not meeting contract documents. It's kind of more of an issue. So if you agree to do it, it's in your purchase order, minute meetings, and things like that, then it's most likely an expectation. Requirements get a little bit more. Now, requirements kind of vary. There's code requirements. Jason talked about 318, he talked about the code, things like that. Then there's specifications. Now, here's the problem with the codes. Most codes are adopted by the building official. They see our 318 means very little unless it's adopted by the jurisdiction. Once it becomes adopted by the jurisdiction, it gives it this funny little thing called law. So you've got 318 now, you got 319 now, you got 320 now, 321 now, 323. When this becomes adopted, now, if you're a designer, how many designers do I have? Okay, so if you're a designer, you're going to now be required to design up to about 5 different codes. If you decide to do a swimming pool or something like that that encompasses this, you got 6. So my advice, if you're pretty close to retirement, now might be a good time. Because I promise you that if I take your design, all 5 of those codes, and I give it to an attorney, you don't need all of it. There's something there you don't need as a part of that. So it might be a good time to bow out. Okay. Now, if you've got an issue that you don't meet code, the owner can't accept that, the designer can't accept that, the contractor can't. The only person who can really legally accept that is the building official. Good luck with that. He has no interest in that. So when these requirements become codes, there's no out really to that. Now, specifications, you can make a change. The owner or the engineer. All right, the next thing I want to point out is, and Jason kind of hit on this, no matter what material you're using in concrete, if you've got enough money, if money is not an object, or time is not a concern, you can do anything. And the other part is, Jason went into this. If you look at a lab concrete mix, a lab concrete mix done in accordance with C92 is 8 minutes old. If you take that, run your test on it, you make your samples on it, it's 8 minutes old. Now, if you think you can take that mix, drop it out, and the temperature is ranging from 40 to 80 to 90. Call it 10 miles to 30 miles. Run it through a pump, all of those things, and you have the same mix. You kind of like making a big mistake. So there's a real big difference between those two. The other part I want to talk about is we talk about specifications, we talk about codes, we talk about what the requirements are. But I think part of the problem is the designers don't understand. And I think one of the things we need to do to avoid clashes is we need to get out to the design group and make them aware of what they're asking for. Now, most designers don't have any idea what the issue of reducing clinker content is. They have no idea at all. They don't know what the impact of adding 50% slag, 40% of concrete cast in cold weather. They have no idea what it's like to replace. I just went to a mere 60,000 square feet. If you're doing a 60,000 peak distribution center, you got an FF50 and FL35. So you're going to do this, you're going to place 60,000 square feet, you're going to finish it, you're going to cut joints in it, you're going to wake up tomorrow morning, you're going to do it. Very few people have that understanding of what happens. Very few people understand what happens when you're placing slabs with a laser screed, and you tie all of that back together, about the importance of predictable and persistent steady times. Very few people understand the value of proper testing. I'm of the opinion that one of the big issues we have is we don't test on this product. Whether it's not, but even if many design professionals understand it's not being tested, they don't understand the value of it. They don't understand the necessary to have somewhat of flowable concrete delivered to the project, yet they've got a reinforcing pattern with number 11s on 6-inch centers with a splice every 30 feet. You've got 3 layers of it. And then when you get to a door frame, you have more reinforcement around the door frames. And then to top it off, you're going to put these cool little diagonal door frames. Or a 2-inch bumper thing. Or it's stuff like that. They don't understand that I need to have a way to get something in here to place concrete. They don't understand what it's like to have 3,000 PSI in 2 days. Let's just say that's ridiculous, right? let's just kick that out. We're going to get 3,000 in 4 days. All right, I got to go to and let's just say that I'm looking life in a fast lane. I want to do, and it's kind of slow today. I want to do it 87 weeks. I'm going to kick this out. Now, different people do things different ways, but if I delay that 2 days, I'm saying it's 160 days. Now, you cannot produce that structure at the same budget if you're on it 160 more days. Even if you work out your crews and all of that, you can't do it. It's not going to happen. It's not going to work for the owner because one of the things the owner's got, he's got construction dollars in there. And the other thing he needs to do is get the building going. When he gets the building going, whatever he's using it for is going to generate income. So it's a major issue with not meeting schedule. It's not just a little cost as a part of that. So, yes, it's a different thing. So what if we can't do this? There's always structural steel. I can put up structural steel, I can slab on metal deck. There's a way around this. They build this out of wood. What works in July doesn't work in February. Okay? So if you got the same concrete mix and you're using it 12 months out of the year and you're not making changes in it, you probably got about 3 days to work for working. So you got to adjust things based on time of the year. What works in Phoenix, Arizona doesn't work in 2. Montana. Okay. Now, anybody here live in the Wisconsin area? Milwaukee, Wisconsin area? Dude, God bless you guys with the best aggregates. They're really, really good. But if you're going to produce a 0.4 water cement ratio with 500 pounds, you're going to let that up. You're going to have to carry these serious issues. Most designers have no idea what the term water is. They have no idea what happens if you starve them into water and you continue to add large quantities of atmosphere. I can make that happen in 8 minutes. I may be able to make it happen longer, but that is a completely different mix from one that's got a water can gets you at about 1 or 2 inches or something. Okay, specifications, drawings, structural notes. If you agree to build it, you own it. Kind of in a statement, just because you didn't read it, I'm sorry. The other part is, this technology exists. Can you do what you agreed to do? Sometimes you can, sometimes you can't. Okay, so you own it, what do you do? Well, the cool things I think you can do pretty easy is extend acceptance criteria. And a lot of times I hear in the comments, well, I can't do that because I'm worried about early strengths. But somebody's got this cool little thing here.
You're wondering where that was.
Oh, well, I have no idea what it is. This is a cool little thing here. It measures temperature. It measures maturity. And if you look at the strength in most elements, you typically have, based on maturity, you have a higher strength in the elements. So you can look at things like that. So another thing is that, so you've got a project, you've got a foundation, you've got a column, you've got this. So one of the things you can do is you can say, hey, I don't care about this house. It's got 3 feet of form. I don't care about head pressure. I don't pour that baby out. Smidgen of. Then you can save that, whatever you get, whatever you gain from that to the mixes where you need to have, where you need to have higher release strength. The other part you do is you look at it in the summer, I need less, and in the winter, I need more. Same time about that. So you use weighted options in my last 2. How many people are religious? So if you're religious, you pray. If you're not religious, you curse. Okay. Any questions, comments?